This video previews one of my favorite activities from Math 9, and the idea behind it is imagine you have an investment opportunity that's too good to be true. So this doesn't exist in real life, but it would be amazing if it did. Imagine you have an investment opportunity where, on average, you get back 10% profit for whatever amount you invest. So, for example, if you invest $10, then on average you get back $1. If you invest $1,000, then on average you get back $100. So that part already makes it impossible that it really exists, but let's pretend that it does. And the trick in this activity is that even though on average you get 10% profit, also some of the time you lose the entire investment. So that makes it a little less good than it sounds at first. It's not that you always get back 10% profit, it's just that if you average it out, you on average get 10% profit. So sometimes you get more than that, sometimes you lose all your money. So there's a lot of stuff written here, most of it you don't have to understand. This first line, initialize money. Okay, what that does is that's my way of saying you're going to start with $10. Returned money, in what you get in the activity, there's going to be a function written here, but for this video I've hidden it so that you cannot study it. So returned money, it's going to be some function where you invest some amount and you get back some other amount. Invest step, we haven't talked about if statements and you don't have to know anything about them, but this is a good chance for me to say two restrictions on your bets. You're not allowed to bet less than a penny. That's what this part is saying. And you're also not allowed to bet more than your total amount of money. So for example, you start out with $10, so you're not allowed to bet more than $10 at the beginning. So the part that you're going to be interacting with is these next two lines. So this one, you're supposed to write a function, and you're almost definitely going to want it to be a piecewise function that takes as input your total amount of money, and as output says, how much do you want to bet? How much do you want to wager? So that's why the function is called myWager. So for example, here what it's saying is no matter how much money you have, you always want to invest $0. Okay, so it's most conservative strategy that could exist. So the main part you're going to have to think about is this part. You're going to have to think about what amount do you want to invest. And when I say you want it to be a piecewise function, most likely, that's like saying, well, maybe if you have over $100, then maybe you want to invest a little more than if you have, say, 5 cents. Then probably you want to invest a little less. So that's the kind of reasoning behind wanting to use a piecewise function, potentially. And then this next line, you're also going to use this a lot, but you're not going to have to change it at all. You just evaluate it. And what this does is it imagines you run this myWager function 100 times, and then it's saying, how much money do you have at the end of each of these 100 wagers? So because we're wagering 0, it just stays static at 10 the whole time. So as an example, let me change this function up here to 1. So always invest 1. Then I go down here to test it. Okay, so you can see that it's growing on average, even though sometimes it loses the entire dollar that was invested. Let me run it again. There's some randomness in my returned money function, so it's going to give me a different output, even though I have the same myWager function. So here we see that it continued growing. Let's try a more aggressive strategy. Let's try always wagering 80% of our total money. So I'm saying no matter what total money is, I want to bet 80%, 0.8 times total money. So I evaluate this. Make sure you don't delete the clear myWager, otherwise things might get confused. And then let me evaluate this line. So you can see that investing 80% of the money got up a little bit, but then eventually it went down to 0. I run it again, eventually it went down to 0. Run it again, eventually it went down to 0. And how is your function going to be evaluated? Well, I'm going to do this procedure 100 times. Okay, obviously, I'll find some way to automate that. I won't really hit enter 100 times. So here's one time. Here's another time. Here's another time. So I do that 100 times, and at each of those I look at what's the final value. So I get 100 different final values. And then if I were to take the average of those, then I think the correct strategy, surprisingly, would be to invest everything every time. But that's not a very realistic strategy. Like if you're actually investing your own money or someone else's money, you don't really want it to usually lose all of the money, and only once in a billion times do you get an extraordinary amount of money. So what's a better way to evaluate it, in my opinion? In my opinion, the right way to evaluate it is to look at these final values and take their median. So I do it 100 times. Okay, I hit this return 100 times. And I don't care at all about this 32 up here. All I care about is this final value. I get 100 different final values, and then I take the median of them. And I'll tell you that when I've had students do this in the past, I don't think I've ever seen one get as high as 50 for the median value at the end. So that's like a very maybe unrealistically high benchmark to get to. And it's really interesting that that's so hard to get to, because let me show you something. We start with 10, and then on average each time it goes up by 10%. So how do you simulate that? You simulate it by doing multiplication by 1.1, so 100% plus this additional 10%. And I do it 100 times. So I raise that to the 100th power. I do this multiplication 100 times. And then I evaluate it. I actually don't have to put an n around it because there's already a decimal, so it's already going to be numerically approximated. So on average, if you just invest everything all 100 times, the average you expect is $137,806. So that shows some striking difference between average and median. So on average, this is what you'd expect, but the median value, like I was saying, I've never seen a student group get the median value as high as $50.